Annyeonghaseyo and greetings, 8th graders. Welcome to Geology 12. Today's lesson is going to be all about volcanoes. And if you look at this picture, you can see in the background there's sort of a faint image of a volcanic eruption that happened just last year on the big island of Hawaii. And if you kind of squint your eyes and look carefully, you can see a lava plume in the background. I'll just go ahead and highlight that for you, but this is an area where lava is actually kind of spewing out of the earth and going onto the ground. So anyways, we're going to talk all about volcanoes. We're going to focus on the islands of Hawaii. As many of you should know, the islands of Hawaii are volcanic islands, and there is no better place to talk about geology and the forces of geology than Hawaii, in my opinion. I lived there for 2 years, and it's a very special place to me, so I'll be sharing some of my own personal stories about my experiences there in Hawaii. Hopefully that'll make this presentation a little bit more interesting. You know, I've kind of been struggling with just making these presentations fast and filling them with information and only information, so you don't have to sit in front of the computer so long. But then on the other hand, I feel like those presentations are a little bit boring. So I'm also kind of experimenting with some maybe a little bit longer presentations with maybe a little bit more entertainment value. So let's go ahead and let's talk about our objectives for today. Our content and language objective are basically the same thing. So I want you to not only understand, but also be able to explain the formation and destruction of the Hawaiian Islands. So most volcanoes are created at convergent boundaries. And if you remember our hand motions, convergent boundaries is where you have two plates moving over each other, one moving under, one moving over the top. Usually the plate that's moving under is like an oceanic plate, and then the top plate is usually a continental plate. And so anyways, at these plate boundaries, usually you'll have volcanoes going up. However, Hawaii is a little bit different from other places with volcanic activity because it's not a convergent boundary that creates the volcanoes, but it's actually what we call a hotspot. Now, a hotspot is simply a place where there's literally a hotspot of magma. So the magma sends up a superheated, what we call it a plume. It's like this sort of stream of material up from the core towards the surface. And it's so hot, once it hits the crust, it actually burns a hole through the crust, and through there we have the lava, the magma coming to the surface, and eventually it forms these islands. On this picture you can see that the Hawaiian Islands all have different ages, and the further out you go, the older the islands get. So Kauai is between 3.8 to 5.6 million years old. Oahu is anywhere between 2.2 to 3.4 million years old. And then Hawaii Island, the big island, is only 700,000 years old. And so as the Earth's plate moves over this hotspot, it gets melted, volcanoes form, those volcanoes form islands, and then by the time the island goes above ground, then the plate is moving past that hotspot, and then we have new islands forming all the time. And so we'll go ahead and look at how this hotspot has interacted with the Pacific plate over the course of millions of years, 80 million years to be precise. So if we look at this picture, we can see you know, at the bottom, kind of middle, you can see the islands of Hawaii. And remember, there's only how many islands? We have the Big Island, we have Maui, we have Molokai, and you know, Lanai is also. So we've got Oahu, Kauai, and then maybe Niihau. So we've got about 7 islands in Hawaii. However, we can see on this map there's a lot more sort of structure around the Hawaiian Islands. So these are what we would call the Hawaiian Islands proper, and then going up north we have this other structure which going back from that picture is what we call the Hawaiian Emperor Seamounts. And now these seamounts are actually completely underwater. For this top image, if you went past this area, all you would see is open water, like in this lower left-hand corner. However, if you go beneath the water, you'll find that there are basically sort of these flat-topped islands that are below the surface of the water. So we're going to talk about this process of island creation, and these sets of islands that move in kind of this L shape. They came to exist because the Pacific plate is moving over this hotspot, and as it moves over the hotspot, we see a trail of islands that are created, and we can see way up top, up north by the Chukchi Peninsula in Siberia, this plate is subducting, and these islands are subducting under the plate. So it's possible that the Hawaiian Islands have been around for longer than 80 million years, but evidence that we have only stretches back 80 million years. Okay, let's talk about how volcanoes, individual volcanoes, are created as the hotspot melts the crust over the Earth. So as the crust melts, it creates what we call pillow basalt. And so you have to remember the crust is melting, but it's melting beneath the ocean, right? And so we have this incredibly hot magma which is hitting water immediately. And so it's cooling down super fast. And so what ends up happening is you get these sort of balls or beads of magma forming. They cool down, and then more magma keeps flowing out until you have what basically looks like a pile of puffy pillow-shaped rocks. And here we have an image of what that pillow basalt looks like. You can see it's just kind of flowing out, it's cooling, and yeah, it just forms these sort of round pillow-shaped chunks of lava. And anyways, you get basically a pile of this pillow basalt under the surface, and eventually, you know, as the pile builds up and as the magma goes higher and higher, it will break the water, and then it'll form what's called a shield volcano. Now, a shield volcano is it's very rounded, and it has a very sort of gradual slope. So it's made as one layer of lava flows and another layer of lava flows on it, and so on and so forth until you get a pile that makes a shield volcano. It's just like a very gently sloping mountain. Okay, and so here we have a picture of what a Hawaiian island would look like. We have on the bottom this sort of gray stuff, which is the pillow basalt, and then on the top you can see these alternating sort of dark gray and light gray layers of lava that build up and spread out and form what's eventually going to be a shield volcano. Now I want to also comment on one of the characteristics of Hawaiian volcanoes is that they have this sort of loose, rocky pillow basalt foundation, and so that pillow basalt, it's not very strong. In these shield volcanoes, they're giant, they're heavy. In fact, in this image here, we can see that the Earth's crust is actually bending beneath the weight of this volcano. And so it's so heavy it bends the Earth's crust. And eventually what's going to happen is that this weight is going to cause this pillow basalt to settle, and eventually you're going to have collapses of the pillow basalt, which is going to like break off pieces of the shield volcano. But that happens millions and millions of years in the future. This is a picture of the Big Island. So this is the island where there's currently an active volcano, and you can see that this is a shield volcano. It's just a very, very gradual slope. It's not like a sharp mountain peak. We can see that there hasn't been a lot of time for forces like weathering and erosion to break down this volcano, and also this volcano is still putting down progressively more and more layers of lava on top, and that's why, for example, when we look over here, there's not a lot of greenery. It looks just basically newish. Another reason why there's not a lot of greenery, this is what we would call the leeward side of the volcano. So on the windward side, the trade winds sort of bring in moist air. As the moist air hits the mountain, it rains, and then when it goes to the other side of the mountain, there's not enough moisture in the clouds to sort of rain on this side. So the leeward side is much more dry than the windward side. So one thing that really stands out to me about living in Hawaii is this sort of feeling that you had that you're living very close to the forces of nature. You know, you go outside and you see that you're living on a volcano, and this volcano is being torn down by forces of weathering and erosion, while at the same time a couple islands over, there are forces that are actually, building up an entire island. And so you realize very quickly that nature is a very powerful force here, and it's something that you have to respect and be careful about. Otherwise, you might find yourself in trouble. And so, on as I mentioned in the other slide, you have the trade winds which blow into Hawaii from east to west. And as these trade winds blow in, they bring moist, warm ocean air towards the volcano. And as those clouds go up higher and higher and higher, as they get to the peak of the volcano, it gets colder. And eventually those clouds start dropping their moisture onto the volcano. However, once they get to the other side of the volcano, they've lost so much moisture that they really don't have any precipitation left for the other side of the volcano. So on one side of the volcano, you get these really steep cliff faces. On the other side of the volcano, you get this sort of gentle slope. And I'll go ahead and show you the other side of Oahu. So the picture on the top is the windward side of Oahu. The picture on the bottom is the leeward side of Oahu. So on one side, you can see, and if you look at the top picture, you can see sort of these dark, heavy clouds on the right, but on the left you see these sort of lighter clouds, and that just is literally showing what's happening. These darker clouds are going to hit these cliff faces. They're going to drop rain on this side of the mountain, and you can see these cliff faces are lush, they're covered with vegetation, but once they hit the other side of the mountain, they don't have water to drop, and so you can see that there's a lot of brown on this far side of the island. And so this is just really showing how the forces of nature are at work on the islands. And I'll share an experience that I had with you. I went on a hike to a place called the Ma'akua Valley. And you start out in this valley, and it's the valley is huge at first. It opens up, it's extremely wide, miles across, and then you hike in, and as you hike in, the valley gets more and more narrow. And you keep going, and it gets more and more narrow, and eventually you end up in a stream bed. There's actually no space to walk on one side or the other of the stream. You're just literally walking ankle deep in water. You can see all of these giant boulders which have fallen off of the mountain down below. So it feels quite dangerous. And eventually you get to an area where you can literally put one hand on one wall of the mountain and another hand on the opposite wall of the mountain. And these walls go straight up for like 100 feet. And then at the top you just see this real narrow band of sky over your head, but most of what you're looking at is cliff faces. And eventually you get to the end of the stream, and there's a waterfall, and what you have to do is you have to dive into the waterfall, swim across, climb up the waterfall in order to get to in order to continue further back in the valley. And so this is a picture of a younger Mr. Kwok. My friend and I, we took this hike. We climbed up the waterfalls, and we went back as far as we could go. And it was just a really amazing experience. It's a very dangerous hike, though, so I don't know if I would recommend it for anyone who's not very experienced with hiking. So weathering and erosion, as I mentioned, it's happening all the time in Hawaii, and it's something that you can see very clearly if you just look around. And so this is an image of the big island of Hawaii. It's the newest island. You can see this sort of shield volcano shape. It's very gradual and sloping. And we can even look at this volcano that's closest to us here, this sort of volcanic peak. And let me go ahead and circle it for you. You can see how there's greenery on it, but it still has like a pretty defined shape. And then if we look at this next picture, this is of the island of Kauai, which is one of the oldest islands. We can see what's happened to this volcano. It's completely eroded out, right? We can see that this whole area here has washed away, and what you're left with is this volcanic crater that's eroding, and it's going to continue to erode until there's basically nothing left. And so we can also see this reflected in the islands themselves. We have the big island here on the far left, and this is the largest island It's also the newest island. And then as these islands gradually move across the Pacific Plate, as the Pacific Plate is moving, erosion makes these islands smaller and smaller and smaller. So we have Maui, which is the second largest island. Molokai, it had a cataclysmic collapse. So because so much of it collapsed, it's one of the smaller islands. Originally, it was much larger, of course. Oahu, same way. It was a much larger island that has been collapsing and eroding apart for millions of years. The same goes for Hawaii, or Kauai, I'm sorry. And then further out, we have smaller islands that you really can't even live on. So the fate of the Hawaiian Islands is that they will all eventually erode so much that there's going to be no island left. However, as the islands themselves are eroding, there's a living creature in the ocean called coral, and coral is sort of this living creature that has a hard shell. It kind of looks, maybe some of them look like underwater trees. There are lots of different types of coral, but nonetheless, the important thing to know about coral is that it grows in very large groups and it creates structure around the islands. It creates almost resembles like an underwater island around the island itself. It grows around the island. Lots of living things live inside of the coral, live inside of coral reefs. And once the island sort of crumbles into the water, all that's going to remain is the coral reef. And then as Hawaii's Pacific Plate keeps moving further and further north, this coral can't survive in the colder waters, and so the coral dies off, and then what you're left with is the remnant of a volcano, which is either a guyot, which is like a flat sort of table-like remnant of a volcano, or a seamount, which is just basically a triangular underwater remnant, a cone-shaped underwater remnant of a volcanic island. And so here, if we look at this picture, we can see the process of a volcanic island being built up on the far left. Then it becomes a sinking island. I don't know why they have guyot here, but it's in the wrong order, so just ignore that. As the island is sinking, coral is sort of creating a home around the island. It's creating what's called a barrier reef. When the island finally sinks down beneath the water, what you're left with is the reef, and that remaining reef is called an atoll. That water inside of the reef is called a lagoon. And then eventually, as the Pacific Plate moves further north, that reef dies off, and then you either end up with like this table, flat-topped mountain called a guyot, or you end up with a conical underwater mountain called a seamount. And above we have a picture of Midway Island. This is an atoll that is located in the Hawaiian island chain. You can see that the only land that exists right now is this little tiny slice in the right-hand corner. And if you even squint at that right-hand corner, you'll see that there's a straight line etched into that island, and that's an airfield, right? So it's big enough to have a small airport. I think there was a military base out there. I don't know if it's still there. There's a big battle fought at Midway during World War II because Japan had a base there. Anyways, the point being is that you can see this circle where the island used to be, which has now sort of been taken over by coral. And eventually, as the Pacific Plate moves further north, in hundreds of thousands of years, this coral is not going to survive, and this island that remains in a corner is going to erode away, and all that's going to be left is either a flat-topped seamount or a conical seamount. So that's it for our lecture on volcanoes and the creation of volcanoes in Hawaii. If you have any questions, please feel free to hit me up at sjkwok@sejongacademy.org. You can also contact Mr. O at hoh1@sejongacademy.org. I also have office hours from 9:30 a.m. to 10:30 a.m. every day. Feel free to pop in, ask me any questions that you might have about this, or any of those strange questions that you loved asking me at the end of science class as well. Also, thank you to everyone who gave me a shout out for Teacher Appreciation Week. I will write you back. It's just a late night tonight, and I'm trying to get to bed, so it's going to have to be later. Thank you again, and have a great day. Peace.